Hello class, it's your favorite student teacher here, Mr. Dubé. Today we're going to be looking at the first day of the statistics unit. So before we dive into standard deviation and variance, let's refresh ourselves on population and sample. Take a moment and copy these notes down into your notebook now. So population. Population is describing the entire set of possible data. So comparing that with just the sample, which is just a chunk, a smaller portion of the entire data set. So we're going to be using these terms today. I want to make an important note here though. The population form should be used unless a random sample is being analyzed. So we should always think first population unless you see specifically to use the sample form. So let's begin. Standard deviation. Take a moment and copy down standard deviation and variance into your notebooks. The standard deviation is a measure of how far our data deviates or moves away from the mean. So, special note here, the larger the standard deviation is, the more spread out our data is. Or in the opposite direction, the smaller our standard deviation is, the more close together or consistent the data is. So, referencing your terms to remember sheets in your memory books, you should know how to find our standard deviation off our graphing calculators. You see that on our graphing calculators, we have two types. The standard deviation of the sample, S sub x, and the standard deviation of the population, sigma x. So variance actually relates to our standard deviation. If I was a statistician and I was calculating standard deviation the old way before having these fancy graphing calculators, I would have to use this very long formula, and I would actually find the variance first. But now, we might run into some questions that ask us to find the variance. So what we would do is we would take our standard deviation, either the sample or population, and square it. So here I have S sub x squared and sigma x squared. Take a moment and make sure you got all the notes before I go on to the next page. Alright, very good. So, let's start off with this first example. The data displays the frequency of scores on a 10-point quiz. So this quiz is out of 10 points. The frequency is going to represent the number of students that scored that many points. I'm asked to find the mean, the sample standard deviation, and the variance. So, very important here. We notice that it says sample. I'm going to double underline it because it's very important. So if asked to find the sample standard deviation, I know that I'm going to be searching for S sub x. So take a moment and try this on your graphing calculator at home if you have one. So what I found using my graphing calculator is out of the total 27 students, I got my x bar. Remember to be referencing your terms to remember sheet. I got x bar to equal 8.10638. Is that how I want my answer to be? No. I know that I need to round to the nearest tenth. So I would get 8.1. So again, I need to find the sample standard deviation. So I'll be looking at my graphing calculator for S sub x, which I found to be 1.28932, which is equal to, when I round to the nearest tenth, 1.3. Simple, right? Those are both right on our graphing calculators. Now I'm going to ask you to do a little bit of calculation and find the variance. So what I need to do is I need to square S sub x. I'll square that. And what I get as an answer is 1.66235, which is equal to 1.7. Take a moment and write down all these notes. Let's look at example number 2. So here I have a snowstorm problem. I am given my data set which includes the number of inches over the past 4 years. A snowstorm of note is when we have snowfall over 6 inches. So I have a data set of all of our snowstorms of note. I'm asked to find the mean and the population standard deviation first. So this is going to be different from the first question. Instead of looking for S sub x, I'm going to be looking for sigma x. So what I found for my x bar, my mean, I found that to be 9.4556. I round that to here. Here I'm rounding to the nearest hundredth, a little bit different than the last problem. 9.46 inches. And I got my sigma x, my standard deviation, equal to 3.74347, rounded to the nearest hundredth, 3.74 inches. So now there's a second part to this question. I'm actually going to ask you to do something with this information from our calculators. How many of the scores fall within one standard deviation? So to calculate my standard deviation, I need to be looking above and below. So first, let's find out how to calculate above. So one standard deviation. One standard deviation above. That's going to be equal to 9.46 plus 3.74. When I calculate that, I get 13.2. That was a bad 13, my apologies. 13.2. And now when I calculate below, one standard deviation below, I would just subtract my standard deviation from my mean. So I'd get 9.46 minus 3.74. That would be equal to 5.72. So here, the question was how many of the scores fall within one standard deviation of the mean. So what I need to ask myself is how many of the snowstorms of notes, here we talk about it in scores, how many of the snowstorms of notes fall between my range of 5.72 to 13.2. Let's take a look back up at our data set. I'm going to underline each of the data points that falls within that range. So 7.1 would fall in there, 9.2. Go ahead now and in your notes, underline each one of these values. Whoops, made a little mistake there. 14 isn't in that range. I should find only 3 data points that don't fall within that range. So what that means is how many of the scores fall within one standard deviation? 15 out of 18. All right, very good.